I welcome you now to the model transformations. So, the basic theory we have seen that there are four viewpoints: CIM, PIM, PSM, and PDM, and there are four levels: M0, that is user data level or system level; M1, terminal model level; M2, meta model level; and M3, that is the meta model level, that is MOF. So let us start off with the model driven transformation. So what exactly we mean by the MDA modeler's graph? Why model transformations are necessary? Just see to it, the levels of abstractions are been increasing, that is from M0 to M1 to M2 to M3. The levels of abstractions are being increasing, whereas from MOF to the real world object layer, there has to be model transformation that has to be done. So modeler's paragon will be indicating model A, B, C at variety of the levels, and then you can have with the machine code realization when you are there reaching to the PDM. Now CIM, PIM, PSM and PDM. So moving next is this is how the things are being arranged. M3 is the MOF layer, M2 UML layer with the RDBMS support, and UML model that is existing at M1 layer, that is the use case diagrams drawn by you or the sequence diagrams drawn by you are been standing at the terminal model level or UML model level that is being done with the RDBMS model. So you have to define the transformation. This is called as horizontal transformation, and you will have to have the MI class name from where the current UML diagram. Let us say you are drawing use case diagram. For that, you have to collect the actor, the use case, the stereotypes from the MOF. Then you can submit it to the terminal model. Going next is the MOF class name table. So this is the actual implementation. So that will be transformed using the transformation rules and transformation engines. So you have to apply the transformations at the M1 layer when you do the UML model to RDB model transformation. So you have got the UML class person, and the name of the person will be there with the RDBMS table, right? So just try to quickly cope up with this scene. From M3 you will be deriving M2, from M2 you will derive M1. You will have horizontal transformations between UML and RDBM and UML model to RDBM model. You derive the MOF class name, and there it has been interpreted in terms of table, and then you can have the, let us say, class, and the name is, let us say, the class name is person. So you will create a table for person, right? Going next, transformations, they are being defined at the meta level. They are being defined at the meta level. They are executed at the model level. So there are two models. One is the source model and another one is the target model. At the source model, you have the definition. At the target model, you have got the execution. So you can have the replacement, addition and removal of the elements by making use of inter-language transformation or intra-language transformation. That is, likewise with the system elements, we know intra-system linkages are stronger than inter-system linkages. That is, for an example, if your hand is a unit, the bone structures and the muscles are been intact, right, due to the intra kind of an linkage support, right? But inter means when you are handshaking with something, isn't it at the same level or something different, then that will be a weaker kind of an handshake, right? So, transformation makes use of that principle also. Again, to remind you, there are two types of models. One is the source model, another one is the target model. And definition of the transformation is been done at meta level. Execution has been done at the model level. Transformations are based on what? Target language limitations. So, target language could be Java or so and so on. What you have to do? You have to interweave the aspect models because multiple aspects are being represented by the models, right? This we have seen in our previous presentation. So UML-A transformation 1 takes it to UML-B. You are conquering persistency. Transformation 2 will be generating logging. Transformation 3 will be generating the language, right? So going next, you can have the CIM and multiple PIMs. CIM and multiple PIMs. These are all PIMs. And there are multiple PSMs, right? So PIMs are standardized and portable. So it means that they are not implementation specific. So PSMs are typically proprietary and they are not portable. Example here they have been mentioned that I can read is .NET model, J2EE model, Corba model, and so on, Windows XP model, WebSphere model, Orbix model. Okay, so many things. So what do you do at the end of the day? The component implementation here and the platform independent binding, okay, through JMI or an movement, yeah, Java metadata interchange, right? And through that you have got the lollipop, okay, for indicating MOF mapping, and you create the MOF compliant model. So the source model, that is MOF compliant model, is transformed into MOF mapping and it is been transformed into component implementation. So whether the PSM is being needed, just see to it. PSM specific component is always been dependent on PIM component. This is the story, right? So here you have got platform independent components, the three units, implementation and platform independent binding, right? Now here the first unit will be interacting with the external world through the lollipop, and this in turn will communicate internally with the PI components, and the infrastructure for this could be EJB, CCM, .NET, and here you have got the platform independent configuration. So now in the other turn, that what we can have is the EJB and Corba, they can have separate kind of an, implementation specific scenario. Corba will have its own lollipop, okay, and have own realization, and EJBs they can have their own representations, right? So as the things are been varying, okay, in terms of the infrastructure, PIM is not been varying. PSM will be varying. Okay, likewise you can see Corba here, EJB here. Something else could be also here. Why you will say why not .NET? Yes, it could be there. Yeah. So model driven implementation will have reflective binding, right? Now reflection, isn't it? Mirror imaging, in short I can say. Okay, reflective binding of PIM will create multiple platform independent units and configurations, and that can be done by using wrappers, bridges, states, and maybe implemented using the generic patterns. So the mainstream of OAC says to you that if you map it between abstraction and executability. Then you have got domain modeling, then you create domain business model, then the requirement analysis, then specification model, that is the UML diagrams, then the high level design, that is in terms of the class diagrams and so on and so on. Then detailed design refined to realize the source code, and source code to executable code translation. That is, source code is being written. Does it mean that it is directly executable? The answer of that is no. So you have to migrate it to the executable code. Next is abstraction versus executability scenario with PIM, PSM. Right. The earlier diagram was about the SDLC cycle, previous example. Here it is with the PIM, PSMs. You have got PIM meta modeling and profiling. You create PIM meta model, that is considering the diagrams that you have drawn, and then with the help of a high level design with UML, OCL or case tools, any of your choice, then you create the design model, then use OCL concepts to tag to PIM to PSM translation. Once that is been done, then you do the profiling and then can have PSM to source code translation. Source code is there, to the executable you can map it. Now the third thing is about UML programming scenario. You have got the requirement analysis, design, okay, the traditional kind of and stuff, isn't it, with the SDLC. Next in parallel you can have PIMs, then you can have the mapping of the PIMs to the PSMs, right, and then PSMs to source code translation or transformation development. And then once you do that, you are available with the source code translation, and the source code is been migrated to executable code. So how do we begin with the MDA process? Meta model, domain model, domain dependent model, CIM meta model, create application model, create requirement model, have the conformance, generate the application software independent model, generate the PIM and latch it to the meta model, platform model, then create application specific model and then application source code and textual meta model. At the end of the day, you create the testing meta model. But the story comes in with the use case driven and architecture centric stuff. So test the code with the help of testing code meta model. So artifact we use application A with the PIM with the CIM support, migrate it to the PSM model, take application B, test application program with platform P, that is testing model AP, that is A stands for application, P stands for platform, and then platform Q model, okay, for A. This is talking about testing AQ, multiple combination kind of models, and then mapping up with the application B and testing BQ. The next thing is automated design process. CIM to design transformation to PIM model. Requirement models, they will be having the domain computation independent model. You perform model transformations through the transformation engines. And then later on, you can have the implementation, that is PIM to PSM transformations with the help of the transformation rule set that has been defined by transformation engine. And then code generation, how to generate the code, have the PSM meta model as the input, have the code generation transformations, and then have the source code meta model. Now here with the PSM, the background of PIM has to be understood. You can use the sequence diagram or state chart diagrams or activity diagrams for generating the code, right? So reverse engineering, now the difficulty comes in. Up till now we were been talking about forward engineering, that is from CIM to PIM to PSM to PDM to source code and to executable code. Now from executable code to backward direction, that is reaching out to the PIM meta model corrections. So have PSM to PIM reverse engineering transformations and do that. But it is not that easy, isn't it? You have to trace back the root. You have to have a separate rule engine to do that. Okay, so this is an overall layer architecture, okay, system layers, right? I will not discuss that. So what should be the aim? You want to have the requirements definition, you want to integrate and test, have executable UML, platform specific mapping, then have design tagging and have automated code generation. Okay, automated code generation. Going next, let us come to MDA mappings. Right. MDA mappings. What it provides? Provides specifications of transformations of a PIM into PSM. Again, PIM has got the basis of CIM, right? So now, model type mapping, very important. Model type mapping specifies mapping from any model. Any model. Now, PIM consists of how many models? Beginning with the use case model, ending towards the profile diagram, right? In UML 2.x, right? And have the PSM language. So there has to be a language, PSM. Yeah. So this is not at all theoretical, right? Model once and generate anywhere, right? It is not write code and generate anywhere, right? It is about model once and generate anywhere. So we should have PIM language first up, just like we have what PSM language. So the PIM elements has to be tagged in, isn't it? Just like a stitching kind of a job you do. Stitching, have you done it? A button you take around, a thread here, and then you try to stitch around. Yeah. Directly you cannot stitch. With the help of certain instrument you stitch. That instrument is very much important. Yeah. If you are doing it with the hand, that will indicate, manual kind of stitching. Automated stitching means we are using the machine there, isn't it? And that is what is the beauty. Manual tagging is always having limitations. Yeah, so therefore you should have the migrations which are consistent enough. If they are well formed, then and then only you can have PIM to PSM mappings in an orderly way. So a meta model mapping, specific example of model type mapping. So therefore, let's go ahead. It gives about the rules or algorithms expressed in terms of instances which specifies the PSM languages. So now this is extremely important. Okay, what is important? What is the crux that I can say? Okay, with the transformation is the model instance mapping and the marks. If you don't know these two things, the model transformations is unknown to you. I repeat again, these two terms are priceless terms in model transformations. First one is model instance mapping, okay, where you identify the model elements, right, which are required to be mapped in PIM, given a choice of certain specific platform for the PSM. The model instance mapping model instance mappings, that is the use case diagram that you have drawn, will define marks. Now, what are the marks now? A mark represents a concept in PSM. Now, a button has to be stitched for a shirt where the stitching has to be done, isn't it? You cannot put up a button anywhere, isn't it? There has to be specific place where that button can be placed, right? And that placement is being suggested by a mark. That is, a mark represents a concept in PSM. If you don't know this concept, how you will do the PIM to PSM mapping? That's why I said that these marks are important, isn't it? Okay, another example is that the marks, they are the indicator of how an element can be transformed. A use case can be transformed, right? An object in a sequence diagram can be mapped. A state can be transformed. A transition can be transformed. A pseudo state can be transformed. Yeah. The marks being the platform specific are not a part of platform independent model. Just see to it, okay? They are not the part. They are independent. Architect, they take the PIM as the input and marks it. Just like a pure cloth, they are given to the tailor master. The cutting has to be done by the tailor master, right? And specific marks have to be done, okay? Where the stitching has to be done, where the buttons are required to be put up, and how one should wear it. Yeah. Backward, okay, buttoning will not help you, isn't it? Yeah. Nobody is having such a kind of an shirt, okay, which has got pockets from the back side, right? Anybody has such a kind of an t-shirt, okay, there is an extremely, okay, has to be put up, okay, in one of the modern wonders, isn't it? So many wonders are there in India. So your t-shirt can be taken as a wonder, right? Which has got pockets at the back end, okay, pockets, right? Design could be there, slogans could be there, okay, which can be written on the back, right? Back portion of the t-shirt, right? But having a collar, isn't it, at the back, isn't it, is not a, I think, fair enough idea, isn't it? This is an exceptional effort that I am taking, isn't it, so that I can do that. Okay, that is your personal opinion. So sources of mark, where these marks can come from? They come from the classes, associations, or other elements. They could represent the roles from the models, right? Stereotypes of UML model, that is include, extend, data store, and so on and so on. Element from MOF model. Every classifier I would name, that is class, use case, component, the node, everything will come, okay. And the role, okay, a class, person, the role is a boss, or the role as an employee, the role as an husband, the role as a child, isn't it? These all are being indicating this set of marks, right? So they also specify the QoS requirements, that is quality of service requirements on the implementation, right? Proceeding next, after finding out the marks, you can build set of marks, that is, they are being mutually exclusive alternative mappings, right? Why they have to be mutually exclusive, okay, you can think, okay. Bidirectionality, dual interpretation has to be avoided, so that's why set of marks has to be mutually exclusive, right? So therefore, a set of marks, instead of being supplied by a mapping, may be specified by a mark model. So Mark model is a separate kind of a model which is independent of any particular mapping. So its job is to gather the marks, isn't it? Right? So just see to it. For a person, a garment has to be stitched up. The tailor master has his registry. I hope so. Once in a while in your life you may have visited the tailor master. Okay, takes up okay the readings of yours and writes it down. Okay, writes it down in certain notebook. Alright, and according to that, the design is been prepared. First, the cutting has to be done, and then the stitching has to be done. The outside stitching has been done first, then the internal stitching has been done. Okay, and the embroidery work, okay, etc., that follows at the end. But that registry itself is very important for a tailor master. Okay, so what you can say to the tailor master? 1 month back, I stitched okay 2 pants. Okay, now this is only the cloth. Okay, stitch it now. The next time, the tailor master will not take okay the parameter set of yours. Yes or no? Yeah, height okay and so on. Isn't it? He will refer to the uh, dictionary, isn't it? Dictionary against your name. What was the thing that was being written? And that is too on a separate page, right? Doesn't mix up with the people, right? Well, templates. What are the templates? They are parameterized models that specify particular kind of an transformation. So templates is a kind of an old technique where rules can be used for transforming pattern of model elements. Right? So this is an older technique working around with the templates. Right? Mapping language, very important. Mapping is specified using some language. Right? So transformation languages, they are existing. To just to tell you how many model transformation and mapping languages they are been there, they are more than 20. Yeah. QVT is coming from, OMG, right? QVT. QVT is specification, query view transformation. Query, you understand what it is? What it is, query? It is a DML statement requesting certain information. View, you are already knowing. It is indicator of certain abstraction. Transformation, you are already aware about. That is source model and target model is there. And the issue here is portability. Without this, you cannot gain the portability. Next is marking a model. I have explained this process, I hope so. So let us skip this. Okay, several times the PIM can be marked from different kind of mappings, and then the end PIM model will be ready to migrate from the source model, that is from the source use case diagram, to the PSM model, which could be code centric. So let me go next, okay, to transformations. This I have covered already. So model transformation, mapping of model instances onto another lower level model instances. That is, now you are coming downwards, right? Starting from PIM level, you migrate to PSM, to PDM, to source code, to executable code. So automated generation of models and codes. Okay, that is what is the ultimate goal is. So how you begin? You have got 4 things: CIM, PIM, PSM, and PDM, PL specific things. So you do the mapping, you take up the source model. Now be very sure, okay. Go through this slide very carefully, watch it very carefully. that is the source model is a PIM. When you apply transformation, the transformations should create the target model in terms of PSM. So you may create this thing only with the help of source meta model and target meta model. So first of all, this source and target meta model, they have to communicate. Then and then only this transformation can apply. Are you understanding this? Very simple common sense example I will tell you that somebody's arranged marriage has to take place. That is, the source model is the bride and the target model is the groom. Right. So who is the source meta model? Mother and father unit. Right. Mother and father unit. That will be the source meta model and target meta model for bride and groom. Right. First of all, they should agree above. Then there is certain charm in that. Okay. Next, you can have this migration by doing the definition of transformations, creating intermediary meta models, and multiply you do the transformation till you reach the target model, isn't it? Yeah. So multiple transformations are being there. It's not the case that you will be transforming only for once in a while and your job is over. Going next, just see to it, if there are 1 lakh developers, okay, then there will be, let us say, project managers, quality engineers, maybe 50,000, yeah, that is architects, platform experts, they may be there, okay, wrongly, one more zero has to be deleted, 5,000, okay, could be the figure. And meta modelers, they are counted in numbers of 100. 100 is also a great figure, okay. I would restrict it to 10, 500, 5,000 and 5 lakh, right? Good. Going next, here is the case. Whatsoever I have said up till now can be realizable with this diagram. You have got source model and target model. You have to have the transformation definition and you will take the help of transformation tool. More than 20 transformation tools are being available this date, right? Right from text to text transformation, text to model transformation, model to text transformation, model to model transformation, horizontal transformation, vertical transformation, many of these opportunities are been existing. The transformation is automatic generation of target model. Automatic generation of target model. It means that it's not necessary to redraw the target model according to the transformation definition. A transformation definition is a set of transformation rules. Now, what is this transformation rules? They describe how a meta model in the source language can be transformed into a model in the target language. The aim is, the ultimate aim is to reach from the source model to the target model. So without meta model support, this is not possible. Without the transformation rules, it is not possible. So what is the transformation rule? It is description of one or more constructs in source language that can be transformed into one or more constructs. One or more constructs. I am repeating again, one or more constructs in the target language. So you should have the clear-cut vision of this diagram. You should remember this diagram. I mean forever when sir you will be doing MDD, right? So what happens is exactly, just repeat me quickly, metadata, data about data, meta model, model about model, meta language is language about language. So here our previous diagram will come, source model, transformation tool, target model with transformation definition. But this transformation definition has to match the language of the source model and the language of the target model. And this has been done with written with the transformation definition language or TDL. And both of these languages, they follow a meta language, right? How beautiful it is, okay? Yeah. So meta language must be there, okay, which is interpretable or should take you from source model to target model with the help of TDL and transformation definition. Alright. Going next is types of transformation. Direct transformation to code, which is dangerous. Record of transformation, which is a good kind of an indication that you can preserve the record of what transformation happened, so that the next time if the thing is being useful, you can do it. Now, how to mark? Okay, just see to it. PIM, a particular platform is being chosen. A mapping for this platform is available or is prepared. Both of the cases are the stories. This mapping includes set of marks. Now you know the marks is a concept that has been existing with PSM. So marks will be having mappings to the platform and these mappings from PIM to PSM. So the next stuff is PIM to PSM migration using the transformation specification, and then you do the model transformation from PIM to PSM by having the variety of platform independent types. And then what you have to realize that a platform is a coherent entity. Okay, it has got generic capabilities and the features as well as platform specific types. They have mixing classes and composite classes. So varieties are been there more, okay, that you can realize with the PSM. Next is the model merging. Two models are been there at PIM level. Two use case diagrams are been there and you are required to merge them. How you will merge them? Again you will use your knowledge, right? What is that knowledge? Knowledge created with the help of marking. That is, have additional information, mark the PIM, okay, have a patterns associated with it and do the PSM, right? So multiple models together. There could be two use cases, one use case, one sequence, another one is state chart, okay, that may lead to scenario. Now this is the notation for platform, right? This pi like notation is notation for the platform, right? So interoperability is being indicated by lightning notation, right? So there will be now a question for you to answer, right? There is a question for you to answer. Just see to it. PSM, same application and platform, different viewpoints are been there. What counts as a platform? In the first case, after visualizing two things, okay, in the platform, you can reach out to the platform. Just by visualizing one particular story, okay, the application program, okay, knows about only one exterior stuff, two are hidden. Nothing is been shown to the program. Dear program, don't bother about anything else below. We will manage that. So which one is better as far as portability and compatibility is concerned? Model 1, which exposes double level details, single level detail, or nothing. The correct choice, the answer is 3. Okay. Going next, benefits of MDD. It's flexible, simpler, and okay, got quality improvement. Updated documents could be there, but you have to give time. All right. time. It will take up your patience, because modeling the system itself is a tough ask, which is not uh, for the people who are looking at shorter results. Next is why difficulties are been there in adapting to embedding, because it will look forward for patience and pressure. There is a shift in development culture. The staff is not ready for modeling. We want prototyping. We want to have making use of programming languages. We want to just rely on data science. We want to just rely on some of the domains like that. Okay, and incomplete or not integrated tool chain, isn't it? It can be also uh, another thing. Okay, one of the best breed example that I can tell you, I have witnessed many projects which are just using software tools, and they are writing just the binding mechanism and showing that this is an uh, great software. People have commented like that. Okay, these people were been felicitated. Okay, so meta model we are already aware about. MOF stands for what? Meta object facility. Now this is the MOF model. Now you will say that this is a very big model. Yeah. So I leave this MIF meta model. I will go to UML meta model, right? Straight away. You will say that again this is more tougher than the previous one. Okay, my dear friends, it is not like the case. So you have to have certain order in which you can start. So now quickly try to understand UML meta model in 2 minutes, right? So you begin with the bottom-up approach. Okay, data type, primitive or enumerated, or programming language specific. Now, the data type, the class, interface, node, subsystem, use case, components, they represent what? They are all the classifiers. They are all the classifiers. How they are being grouped in? Subsystems and the models are being grouped in as packages. Right? Packages and classifiers, they make up the namespace. They are having the namespace for declaration purpose. Now, UML is having structural diagrams as well as behavioral diagrams. So you can see that UML can represent structural features or behavioral features. Structural features, of course, at the extremity end, they will require attribute, whereas behavioral feature, they will be indicated by operations and the methods incorporated. Okay, that is the body. Now you can have with the classes the associations. Then the association, we know that it is by default bidirectional. It is between two horizontal classes. You can use the relationship generalization between the classes. You can have links. You can have multiplicities. You can indicate the relationships. Similarly, you can have aggregations here, compositions here. So link, relationship, comment, features, generalizable element, namespace, parameter and instances, they are all model element. And model element is an element of element, right? That is imported element, right? This is how we can understand the UML meta model. Shall we do it once again quickly? Yes, of course. I know the answer. Data type we began with, that is int, float, boolean and so on. Yeah. Then we have got classifiers, class, interface, data type, subsystem, node, use cases, component. They make up the subsystem make up the packages and model. Classifiers range we have specified. Namespace is for declaration purpose. The features of UML can be there into structural and behavioral. Attributes, they specify structural features, whereas behavioral features are with operations and methods. Association classes, okay, there is a commonality between two classes that can be referred with the association class. And association by default is bidirectional. You can have the association ends You can indicate multiplicities, okay, one to one, one to many, many to many, and link, relationship, comment, feature, generalizable element. They are all elements of model element. A model element is imported from element. This is how you can understand simply UML meta model. And a UML meta model is extracted from MOF. Here also you will see import mechanism. Model element was imported there, which was having namespace. Generalizable element as package and classifiers. We have seen association, classes, data types, primitive, structure, enumerated, collection, alias, behavioral feature we have seen, structural features we have seen. So UML meta model is derived from MOF model only, right? So this is the crux that we can see, and this is one of the example of class diagram, use case diagram. Here you can see use cases can have include extends relationships. It can have instances. A use case itself is a classifier. Actor is also a classifier. You can have the stereotypes indicator, and the extension points are derived from model element core. So other thing is that this is a sample use case, or which is a very bad example of use case that I have brought it for you. Next is the state machine diagram. Like I have read the use case meta model. You can have all of these meta models related to diagrams in OMG's superstructure specification. Visit to www.omg.org and try to look forward for specifications. There you will be finding the superstructure specification for UML 2.0 diagrams. There you will find all the UML meta models. So this is for state machine, okay, extension mechanisms, and here we end up the session. With note that model transformation is a very big area of research where you want to do automated transformations, starting with the CIM to PIM, especially from PIM to PSM to PDM, that is from source code to